Today on the MrMaple podcast, Matt and Tim discuss plant breeding and plant genetics with plant genius, Dr. Susan Wiegrefe.
Guys, welcome to the MrMaple Show. I think we have a really good show for you today. Today we're going to be interviewing one of the top plant breeders for Japanese maples. And she really is one of the most knowledgeable people on the entire planet when it comes to genetics, plant material, woody ornamentals. There's really not a category that she's not one of the most leading experts you can talk to. And I think you're going to like this interview we do with Dr. Sue Weigriff.
That was Matt. I'm Tim. We're just so excited about today's interview. Dr. Susan Weigriff, she has a Doctor of Philosophy degree and plant breeding and plant genetics, a botany minor at the University of Wisconsin-Madison. She has a Master of Science degree in horticulture, a Bachelor of Science degree with distinction in horticultural science from the University of Minnesota, St. Paul. And she has been somebody who inspired us, former president of the Maple Society of the North American branch, and she's inspired us so much when it comes to maples, what's out there, what to just keep looking forward for the future. And so I think we've got a good interview for you today.
Yeah, guys, if you like Japanese maple content, definitely subscribe to us on any or all major podcast platforms. Give us a 5-star rating. That goes a long way toward getting our channel out there. And definitely sign up for our weekly emails here on MrMaple.com. We're always adding 10 new plants every Tuesday at 10, so there's something interesting coming down the pipeline. I think you'll definitely want to be a part of that. This interview, I think, is going to be a fun one for you. It's definitely next level on, anytime you're talking to Sue, it's next level on plant information. She's one of the people that I consider the ultimate source for plant information, and she is one of those people that understands genetics of woody ornamentals at a level that is just so interesting. I love to pick people like this as brain. And so I think, I hope you're going to enjoy this interview where we kind of dig in a little bit more and ask her about some of the genetics with Japanese maples.
I remember years ago, Matt and I were so Japanese maple crazy, and we were just ecstatic. We were at the Maple Society meeting on the post tour and the Maple Society meeting itself with Sue Weigriff. And is that how you say your name, Weigriff or Weigriff?
Yes, it is. Right. No, it's Wiegrefe. You got it right.
And Sue just continued to tell us Japanese maples are great, but there's so many other things out there. There's so many other species out there that have amazing traits as well. And Matt and I listened. I mean, we were going to Mount St. Helens. We saw Acer circinatums growing naturally in the wild, and it just blew my mind seeing all these things that Lewis and Clark saw on their expedition. And it just was like, wow, this is amazing. And it opened our minds into, Acer oliveranum, Acer pseudosubodianum, all these other different maple species, Acer campestre, that have fantastic qualities and also some ornamental traits. So first off, Sue, before we get started, I just want to say thanks for really propelling us to open our minds a little more with maples.
Well, thank you for listening. I can talk about maples for hours on end, so you did me good.
That was a fun trip.
You were stuck in the car with me. Yeah.
We recently interviewed Augustine, and we joked that we bonded over the Frank Biles driving us through the mountains there together. If you can make it through Frank Biles driving us to Olympia, you're going to be good buddies for life after that.
Yep.
So, Sue, you were one of the founding members of the Maple Society in the North American branch. How did all that get started?
Well, I had been working with maples for my postdoc. I had received a PhD in plant breeding and plant genetics at the University of Wisconsin-Madison, and that was with the elm team. And so I had a plant pathologist and forest geneticist as my advisors there, and I was lucky enough to get a postdoc with Harold Pellett at the University of Minnesota. And he was, at that time, the ringleader for organization called Landscape Plant Development Center. And his idea was to sort of unite the plant breeders, especially the tree breeders, from around the country and cooperate because there's limited resources. And so at that time, he'd actually done a study, and he said that there are only 7 full-time equivalents breeding ornamental trees or ornamental woodies in the whole United States.
Wow.
And so he said, we got to band together. So that was his mission. And he had received a grant from the Electrical Power Research Institute, EPRI. And so it was a wonderful position for me. And they were lucky to have a new plant breeder coming out, because you can imagine they're few and far between when there's that few people in academia that are working on woody plants. And my mission, or the goal of this research, was to develop smaller statured tree cultivars or individuals that were tolerant of city conditions. And that was really a challenge because most short statured trees are understory, and they have the protection of the overstory, and they're not used to the very exposed and sometimes, well, almost always very challenging conditions on city streets. And so I was given the responsibility of finding a couple of genera to work with, and then going around the number of botanical gardens in northeastern North America, and actually doing crosses. So very quickly, I realized that maples were just a treasure trove. There were a number of different sections, which are subgroups within the genus maple, and some of them would have small trees within them, but we didn't know if we could do any mixing and matching. So I was, one of the first things I did was to work on cross-ability, finding where these specimens were set up in these various arboreta, determining if they were true, determining if I could get actually hold of some branches so I could do my crosses. And yeah, I had a phenomenal time. I went on 2, so in 96 and 98, I went to Arboreta out east, and I would sort of follow the season north and west. So I would start at like the National Arboretum in Washington, D.C., and then I would end up at Minnesota Landscape Arboretum in Zone 4 in Minnesota.
Wow.
And it was a lot of fun, and I also did some lab work looking at, so when you cross two things, you're just putting the pollen on the style, and sometimes things happen and sometimes they don't. And one of the early indications is if you put the pollen on the style and callus forms, then you know that style is resistant to that type of a pollen. And the other thing that can happen is that the style, the pollen tube, so once the pollen grain germinates, it'll send on this tube that'll go down towards the ovary. And sometimes there's something about that style that totally disorients the pollen grain, and it never gets there. So I got to look at under a microscope at some of these pollinations in mid-progress and find out, well, is this one worth pursuing, or is this not going to happen? So it was a lot of fun. I had a lot of autonomy, which I appreciated, but I really gained an appreciation for the vast diversity in maples because I grew up in Minnesota, and we've got a relatively small subset that grow here.
So whenever it doesn't happen, does that mean that there's a natural barrier coming in? Does that mean that we're dealing with different chromosomes? Does that mean that what do you think, if they're closely related, what do you think is causing that pollen not to take?
It can happen as a consequence of a number of different things. One of the, in my mind, rather prominent situations where things don't cross and yet they're closely related is the full moon maple, Acer japonicum, and Japanese maple, Acer palmatum. They actually overlap in distribution. And yes, they do not cross at any, there might be like 1 or 2%. I did not ever find any that crossed. But it could be a chromosome mutation where there's been a flip or something, and then they just don't pair up at meiosis so that there's not a viable gamete formed, a viable pollen or viable egg. But I never got down to the molecular level. I was busy enough just cataloging these and trying to, going back and checking, did the squirrels get them? I had them bagged.
Right.
But sometimes things still happen.
It's such interesting stuff. I mean, the cross-pollination of stuff. I went in and did a lot of reading on Pete DeJong's 1976 thesis on flowering sex expression in Acer. And
that's an amazing book. Yeah.
It is. But then the more you read, the more you realize you just don't know anything. And I'm like, oh my goodness, there's all these different flowers and there's different stages of the flowers to try to identify, to try to look at and doing the crossbreeding work. Do you think most of this stuff on the crossbreeding work really has to be done in a lab to ensure that you've actually cross-pollinated?
Not necessarily. In some cases, the proof is in the pudding. Are there seeds that develop, and do they fill out? Do they germinate? However, there's almost all maples are self-incompatible. And I've seen in other places where there might be a 1 or 2% of the crosses that take, and sometimes they can be tracked down to a selfing event where the same plant produces both the pollen and then it gets distributed onto the style and a seed develops. There are instances of that where it's kind of anecdotal. At the Minnesota Arboretum, there are some Acer griffins, a paperbark maple, that have little seedlings around the base of them. And you say that's kind of fishy because there's nothing closely related to it that's anywhere near it.
Yeah.
So in some cases, it doesn't require, and it's kind of fun because it means that the possibility of non-academics doing some of this work, when you think about like climate change, you say, well, maybe we need to combine plants that have a more southerly heat tolerance with something that has more cold tolerance, and we could use a lot of different people. And one of the things about the Maple Society is that there's all of these people who are just gaga about maples. And it's a way of distributing information around as to what works and what the resulting plants look like.
Now, was palmatum kind of your standard for some of those experiments? Was that the standard thing you were trying to cross with? Did you use that as a constant, or were you trying to cross things like Shirasolidum with Japonicum or Pseudocebolianum, with Japonicum, or was it mostly with palmatum?
Well, after the first year, and I noted that it wasn't likely that we're going to get any Japonicum palmatum crosses. There's this concept called a bridge species, and it turns out that Acer pseudocebolianum, which is Korean maple, crosses with both palmatum and Japonicum.
Oh.
And so it means that you have to take an extra step, but you could potentially get some of the traits from one into the other. I didn't spend a whole lot of time with that group because it's not one of the toughest groups out there. It tends to be an understory species. So I did do some work with it because I was also curious to know, for instance, if Acer genella. So Acer genella is Tatarian maple or MrMaple, depending upon how you split or lump. And they grow out on the steppes of Eastern Asia. And I thought, and it is sometimes used as a street tree or as a barrier planting. And if I could get some of that, combine that with some of the palmatum or japonicum genetics, you could potentially get a diversity of plants that would be attractive to the horticultural industry.
Well, that's super interesting.
So I was trying to do all kinds of some things. Like, for instance, on the Acer Janella, I did. I'm toting around all of this pollen, and I was friends with a corn breeder, and I knew that the corn pollen might only be viable for about 3 to 7 hours. But I also knew that in the elm breeding lab, they would keep pollen practically on a bench top for long periods of time, and it would still be viable. And so trying to figure out, well, if I'm going to go to all of this work and all of these miles and all of these locations, I need to know, am I putting on viable pollen? And so I did a study with the Janella because that was at the end of the whole series. I had some time to sit and look at that, and that gave me some information for the following years. But also along the way, there was a technique that Dr. Bob Marquardt, who had been at the Holden Arboretum in Ohio, and he taught me how to essentially germinate the pollen in a petri plate to make sure that it was still viable as I went along.
This is fascinating stuff.
And that did not require a high power microscope to see the pollen grains germinate. It was just you'd only need a dissecting microscope, and that was helpful. It gave me hope that the stuff that I collected in Washington, D.C. would still be viable by the time I got to Minnesota, which might be 5 or 6 weeks later.
How long did the pollen? Did you ever figure out how long the pollen on Janella lasted before it was no longer viable?
Well, it depends on how you stored it. And so I determined that the best way to store it was over a desiccant in a freezer. And then when you want to use it, you bring it into out of the freezer and put it in a saturated environment. Like often there's these jars that are used for that purpose. So you desiccate it and then you gently rehydrate it, and then you would have a large percentage of those pollen grains being viable. So it could potentially last for over a year, which is helpful because some trees have off years, and you might not be able to visit them each year and harvest their pollen.
Now, with the plants you were breeding with there, were they mostly plants produced from seed originally? Were they species, or were they some grafted and some cultivars mixed into that research as well?
Wherever I could, I would find documented wild source plants, and that's why I chose the locations that I did. There's a group of arboreta that have been going to China in particular, but they've also gone to Russia and to the Republic of Georgia. But they have, the standards are very high. You want to be able to infer some things from the seed location. You want to be able to know, yes, it was actually tolerant of conditions in this mountain pass in Georgia, as opposed to, well, this plant grows in Georgia, but it might have come from one that was in a lower elevation and not have accumulated those group of genes that enable it to withstand some pretty harsh conditions. So by being able to use plants that had been wild collected and documented and maintained through the years, it gave more credence to this.
Yeah, that makes sense.
We actually here at our nursery, shortly after we got super maple crazy even outside of Section Palmata, we started doing a Go Wild series we're going to have to bring back here at Mr. Maple. Right. And we would go and find these selections that have been wild collected, get permissions from the Arboretum and different Arboretums, and graft wild collected plants and have their provenance. And it made people who were growing out in their gardens really appreciate it, because we'd try to tell the story of, the Sino expedition whenever they went out there to collect this at the same time of looking at this plant, and people can appreciate the species with a wild collected provenance.
We kind of went down the rabbit hole of trying to grow seedlings from a species, then grafting provenance of that species back onto the seedlings. We went nuts with it. I'd probably
you're the team to do it. You've got a nice environment, and you develop the skills and knowledge to go find them. And did the Maple Society help you connect with some of these arboreta?
For sure. Yeah. Oh my gosh.
Curators, and I'm thinking that like Tony Ayalo, that you were able to have.
He's super helpful and such a great network of people to just learn more. I mean, Tim and I've got a degree in history and a degree in political science, so we're not horticulturalists. So it's funny, like our backgrounds. He has a business degree. We learn all this from people like you and people like Tony, and people who are willing to spend the time, Dr. Creech, and people that are willing to let us pick their brains and say, hey, what about this?
But looking through Acer oliveranum seedlings, by chance, we found Acer oliveranum, which is a selection we made called Hot Blonde, which Matt named after his wife. And it's a yellow Acer oliveranum variety oliveranum that grows extremely fast. We're still testing it in zone 5, but it goes down to zone 6. And it has really good yellow color. It's extremely heat tolerant, and a really good orange-red fall color, almost like Osakazuki. And
nice.
And so
for most people, it's going to have the traits they like about, a Japanese maple. It's going to resemble to the average gardener an Acer palmatum in a lot of ways, but it's going to have a little bit more heat tolerance, hopefully, too. It's our goal.
But oliveranum, we saw, has a superpower. I mean, it brings more heat tolerance to something that people love, like a Japanese maple, because this is a hybrid that we found that's just a bright yellow. Are there any other maples that you can think of? I mean, obviously, Acer pseudosubuldianum has that superpower of bringing things down to a much colder zone. Are there any other maples that you think that might have a superpower that we should be looking at and people should be looking at in breeding or in seedling selection?
Well, a couple of things come to mind. One is there is a member of the section Platanoides, which is Myabii. And I think you and I are geared, our breeding purposes for slightly different. Mine was not quite so much for ornamentation. Mm-hmm. It was for survival. When you're looking at city streets, a lot of times they're planted into this concrete rubble. There's hardly any really soil underneath where their roots are supposed to be. Mm-hmm. And so they have to be really tough. And so there's this Myabii is really nice. The Chicagoland Groves has a selection, but that is one that had not been used in the planting palette of a lot of cities previously. That is one that's a newcomer. From the breeding standpoint, the pseudoplatanus, I just have to stop and say that very carefully, is the one of the major maples of Europe. And if you look at the evolutionary family tree of maples, it's way at the bottom. It branches off. And there are anecdotal evidence that it will cross with a large number of plants.
Interesting.
It's almost as though this crossability is an acquired, it's a new trait. Mm-hmm. The original trait was cross-compatibility. But it's also used as the rootstock in grafts.
I was going to ask
really
about that too.
Broad crosses. Not broad crosses, but broad combinations. And so, because I had I don't know if you remember Peter Padaris, but he's an incredible plantsman, and he had seen seedlings of pseudoplatanus and griseum. And I'm going, well, they're not anywhere in the same. Well, they're in the same. Probably what?
Plants don't read books.
Subgenus,
Right.
but they're not in the same section.
Yeah.
And that got me really excited. And if I would have continued with that and had the additional funding to do that sort of thing, I could have gone really wild with that. But that is so. This Electrical Power Research Institute was looking for small stature trees. They didn't want to have to butcher trees in order to keep them compatible with overhead wires. Nowadays, a lot of places are going to boring laterally underground and having buried lines. But at that point, they wanted to also be able to have trees that were compatible with existing above ground wires. And things like pseudoplatanus is not short.
Yeah.
And so trying to, stick to what is my mission. And I didn't pursue that terribly much.
We've grafted a lot of things into Acer pseudoplatanus. Our finding, and just as nurserymen, not as academia, was that some things were more compatible long-term than others. So down the road, some things didn't necessarily stay as happy, 10, 15 years down the road as a universal understock, if you will.
Right, but sometimes if you can get that essentially a nurse graft, then you can, that sign will revert somewhat into into a more juvenile state, and then you can take cuttings. So using it as a means to an end, yeah, it's really sad if you've got a 20-year-old tree that just topples over in a windstorm because it wasn't well knit at the graft union. But sometimes you can use it as a way of getting plants that are difficult to root, to go back to a more juvenile condition so that it is possible.
So I think it's really interesting, though, how these plants, they just don't, there's so many exceptions to the rules because people want to put these rules around the plants and say, this can't breed with this because they're not closely related. But yet there is known hybrids of Acer grisham with Acer pseudoplatanus, but there's also known hybrids with Acer grisham and Acer saccharum, the sugar maple. And then there's also known
saccharum and pseudoplatanus are in the same group.
Yeah, and then there's also known hybrids between Acer grisham and Acer macrophyllum. And it's like,
really?
Yes, yeah, they found some at Heritage. And it's like, what in the world? There's all these different plants that shouldn't be breeding together.
Oh my!
But yet they can.
Yeah. Given enough trials, some of the life will prevail.
Right. Now, you did so much research within section Palmata. Do you have a favorite within that group? I know you certainly did a lot with Circinatum, but did something stand out between kind of the main, like the Pseudo-Seaboldianums, the Seaboldianums, the Chirosalrums, the Japonicums? Was there something you enjoyed checking out more than others there?
Well, I like the leaf presentation of the Seaboldianum individuals that I've seen. I like that upward facing, and that's quite so, because up here I can maybe grow Pseudo-Seaboldianum, but it has a more of a pendulant leaf presentation. And to me, I start thinking, does it need water? So I like that was one, but it's less hardy than pretty much the other three that we've mentioned in that group. There's one called Chinoskii, and its cousin Micranthum, that are gorgeous. They're in the snake bark group, and I would love to be able to grow them.
Do you think I know the Pseudo-Seaboldianum had more, cold tolerant traits for the most part. That's why there's a lot of work being done with that now with places like Isley that are trying to develop series of more cold tolerant plants. Do you think from a nursery standpoint that understock matters a lot, like what it's grafted to? I know most people in our industry are probably putting most of these hybrids straight onto palmatum. Do you think there's a symbiotic relationship there? Or do you think it would be more beneficial for it to be on something like Pseudocybuldianum as well?
I did a whole graft compatibility thing. Let's see. That was.
There's nothing I can think of you haven't already done. That's the best part about talking to you. I can geek out to the max because there's nothing I can think of that you haven't already accomplished.
Well, when it's your full-time job, you just, especially the winters get a little long out here. You say, well, see, what do we try next? I think that was with Talon Buckles. I think he was the one who did the crosses or the grafts for me. We were trying to figure out. I was also working with Cultivars at the time, and Mark Crutland was helping me with that graft compatibility study.
Very cool.
Yeah, I would say you want the understock to be as tough as possible. So, for instance, in the pear world, especially up here in the north central region, grafting anything onto Usuriensis, which is really cold tolerant, is a good idea. A lot of the elms are grafted onto Tumula, which is tolerant of both cold and drought and Dutch elm disease. And so don't forget about that below ground portion, because it does play a large role in how well that mosaic plant is going to perform. So I would think that something a little bit tougher than palmatum might be a good idea.
Mm-hmm.
So one thing I wanted to ask you too is they've done research that on lower level plants, things like a tobacco, if you graft certain resistant roots onto it, sometimes the genetics from the roots will actually show traits in the top of the plant. Matt and I have done some research, not really research, some crazy mad scientist experiments.
Redneck research down here in North Carolina.
Yeah, where we've seen grafted plants display traits of the rootstock that it's grafted on, which didn't make any sense to us in their first time they leafed out, the very first year they leafed out.
No, that's exciting. You get to do this your entire life. I was working on it for a short period. But yeah, there's what they call graft transmissible traits. And it sounds like you're discovering something that is really exciting.
So graft transmissible traits, what does that necessarily mean?
It's interesting. I don't know if it would probably have to be a growth regulator or some chemical or biochemical communication tool that is able to cross that graft.
Wow.
Because no, you're not going to have floating bits of DNA. That's not going to happen.
Mm-hmm.
Yeah.
But if it creates a certain response it just means that there's something that is produced in the roots that then influences the top.
Yeah.
And it can be biochemically, as in shortening, like they do in apples a lot, but it could also be morphologically. So it sounds like you might have some of the latter.
That's super interesting. Now, I'm sure your research didn't do much with Acer fabri, but we're always interested in being in the colder zone. We're really pushing it here in Zone 6B for fabri. Zone 7 factors in more, but I always am interested in how that grafts on palmatum, even though they look so ridiculously different. It's an interesting interesting hybrid possibility there.
But it also grafts onto Acer burgerianum. And so there's this crazy mad scientist to me that wants to use it as an interstock and use a trident maple root system on a Japanese maple and see how big it gets.
Oh,
so
yeah.
Put like truncatum, then pseudoplatanus, then like a tamukiyama on top. Get the biggest motor possible. So
Fun.
This stuff's so interesting to us. I could talk to you all day about this kind of stuff. It's so interesting to us. Why do you think there's so much more variability for cultivars in like palmatum? Why is that one so prevalently used in the trade? And why does that one seem to have more just expressed genetics?
There's a couple of things that come to mind, and I don't know if the second one has been tested. But the first one is it has an amazing distribution.
Mm-hmm.
It goes all the way over into, like over towards Szechuan,
Mm-hmm.
and it's in Japan. It goes up into probably even almost to the Usuri River. So it has a huge distribution. And over that distance, it could have been, different pockets of it could have been isolated at different geologic epochs. And so different clusters of genes, so there's mutations that will be developed only there. So that's one thing, is that it has a huge distribution. I also have the feeling that there's probably a lot of more genetic variability. Back in the day, they used to look at what was the number of alleles at any one locus, how many different alleles are there, how widely distributed are these different alleles in the population.
Mm-hmm.
I bet you there's a lot of more differences all the way through the genome.
Oh, that's super
Because
interesting.
Japonicum has a much more restricted and homogeneous distribution. And so it didn't need to develop, there wouldn't be necessarily a way of keeping pockets of specialized mutations only to one area. They would have been more likely to distribute all the way around.
Yeah.
So that's just my off-the-cuff.
That makes a lot of
Yeah.
sense. It's very interesting. I mean, somebody asked me this at the maple side of Ming too, and I pointed out that, since the 1700s list is one of the earliest lists of Japanese maples, there was already this sophisticated of selections made in this genus in the 1700s. So it's like, if you're already at that level, it's like there's a lot of specialization.
And I think I would guess that there's a lot of human distribution, especially if you've got this little thing in a pot, if you're doing bonsai. I forget what the Chinese equivalent is, but anyway, you can move them around and then get even more combinations.
Mm-hmm.
So it's a fun and fabulous group to work with, and it's been of interest for just centuries.
You've got my wheels turning in my head, because I just got some questions for you whenever it comes to these. You said that sometimes the maples normally don't self themselves. I got a question, because sometimes they've found certain reoccurring traits in certain cultivars, like Scolopendrifolium. If you look through 5% of the time, you'll find something that looks like fairy hair, which is a very, very thin leafed, very slow growing linear that's very unique and very different. If we're not seeing a self in that, what are we seeing when we see?
It doesn't, I didn't exclude it. I just know that they have very strong barriers against it. But almost nothing is 100% effective.
Yeah. I appreciate you explaining that.
We were with the Elm group up at Madison, Wisconsin. We brought in some nurserymen to sort of give us some feedback on what they thought they would be interested from the various things that had been developed there. And it was so funny, because one of the things that they were most excited about were some little inbred lace bark elms. And here we had been looking for, like, reviving the statuesque American elm and having it Dutch elm disease resistant, and they were more keyed in on novelty and ornamentation, and we were more concerned about serviceability and like regreening streets and stuff like that.
I understand that novelty passion, though.
Well, and it's fun to see how Heritage Seedlings has changed their attitude. They used to eliminate all of their unusual things. They wanted a very uniform product line. And then, actually, it's not been that recent, but they started to pay attention to these little unusual things that popped up and wouldn't necessarily throw them in the in the compost heap, they would set them aside and throw them out and see, number one, if it was a persistent trait or condition that they were seeing, or because some of these things kind of go away depending upon the nutrient status and number of other things.
Now,
but they've been, go ahead.
Oh, the Acer circinatum Morton. I think you brought it to a Maple Society meeting and tried to get people to sort of grow it and understand it a little bit. Was that a hybrid that happened through your breeding work?
No, I'm guessing. So that would have been a selection from a plant that was there. One of the things about circinatum is really most comfortable in a more maritime / Mediterranean climate. And Chicago is not that. And so when it grows well and looks decent, it's an individual worth taking note of.
Mm-hmm.
And so being able to say this individual has these traits that we have watched and are persistent over years, then you can say, well, this genotype, not necessarily all circinatum, but this genotype is capable of growing in an expanded range of environments. And so, that was not one of mine. One of the, circinatum didn't want to set seed very well for me, but it was in the mix.
We often have more success with, we're down here in the mountains of Western North Carolina, and the hybrid circinatums certainly, if they've got some palmatum influence, those tend to be the ones we are drawn toward because they have a little bit more durability for us here as well.
Mm-hmm.
I noticed your 1994 thing on overcoming dormancy in maple seeds without stratification. Can you talk a little bit about that? We found that super interesting. I definitely started that. I've read most of your work. And Tim and I are geeks, so we love to check into all this kind of stuff, but I don't think I'd read that much before or really hit my radar. Could you talk a little bit about overcoming dormancy without stratification?
Okay. So a lot of that had to do with, I was working at the Morton Arboretum, and they were part of this group that would go to Asia and bring back these seeds. And these seeds were super valuable, but they weren't very numerous because the seed lot would be divided between all of these different organizations. And if it's a new entity or a new provenance or collection location of a plant, and you didn't know how to treat it, you might be giving it the wrong treatment to help it overcome dormancy. And dormancy can be caused by a number of different things. And that's what I was doing. It was called embryo excision. So one of the things that can cause a seed not to grow is if it's not imbibing water. If it's not taking up water, it's not going to be able to germinate. Well, there's this structure right inside the seed shell, essentially, that is called the integument. And that thing is like a shrink wrap cover that is impervious to water. And so one of the ways, if you a large number of the plants the seeds would germinate if I did nothing more than just take off that integument and put it on a moist sheet of filter paper. And then I would have some in light and some not in light. I think the dark ones usually did better because that's where seeds usually germinate. But,
super interesting.
So that was one thing. If they didn't germinate then, I had a couple of different growth regulators that I could use as tools. Benzyladenine, BA, and gibberellic acid, GA. I use GA3. I could use either alone or in combination. And so if I needed to use those and not just remove the integument, it meant that they had essentially a biochemical dormancy. And by putting them on a filter plate paper that was saturated with this mild solution of one of these growth regulators, you could get some really good. And it was also very uniform and quick. And so, for instance, if you can get them started in February, and then they will have a much longer season to grow, you could have a good. Actually, it might even be useful for commercial application if you've got a niche market that you're selling to. The time involved in sterilizing and removing those little integuments. I had a little lighted magnifying glass, and using these tiny little forceps, and it was tedious. But when you figure that these seed lots are really, really valuable, and so it kind of depends upon how valuable is the seed lot, and can you recover the time invested in the final product.
Oh, thanks for speaking on that. That's super interesting.
Oh, there's a whole nother rabbit hole on that. So, in fact, I did a poster at an IPPS meeting with there was 2 reeds barbers on the West Coast. Anyway, USDA worker down at McMinnville, and she had been working with, I believe, hydrangea, but she was working with this process of making wide crosses. And when you're making wide crosses, sometimes there ends up being a point in the development of the embryo where the endosperm, which is supposed to be the nutritive tissue helping that embryo grow, doesn't fulfill its job. And people have found that there's a lot of partners out there. They had found that if you take if nothing is done, and this wide cross results in a not functional endosperm, then the embryo will grow to a certain stage and then start to deteriorate. With this process called embryo rescue, you kind of let it grow as far as it healthily can, and then cut it out and put it on nutrient auger like you would a tissue culture. And you essentially provide an artificial endosperm, and you can successfully get viable plants from crosses that otherwise wouldn't work.
That's just blown my mind right there.
That's so cool.
That's one of the things I love talking with you, just because it just opens my mind up to so many things. I'm like, okay, yeah, Matt, that tissue culture lab we've been talking about working on here at MrMaple, that's definitely coming in the near future, just so we can have that for our seed embryo rescue. When Acer japonicum, you mentioned too, there's not a lot of variability in it. And Matt and I have always been trying to look through Acer japonicum seedlings, looking for all these different things. We often run into the issue that Acer japonicum often takes 2 years to germinate. For us, with going through its dormancy period, seed dormancy period, before it begins to seed out. And during that process, we face a litany of problems like mice and squirrels that end up finding the japonicums during that full year that we're waiting. And that time is always precious, because the longer you have to wait, the less likely you are to find a lot of neat seedlings, because the animals, the varmints, have went in there and eaten these seeds. What would be your recommendation on our mad scientists here on trying to get in there and treat this so that it may leaf out and come out the first year, if that makes sense?
Okay. I would do exactly what I had done in that embryo excision. You're lucky with japonicum, they've got relatively large seeds. And so you don't have to have the absolute best fine motor coordination. So you could try it with just the wet filter paper. You could try it with a BA. I think it's like 10 parts per million. And then another treatment would be 10 parts per million GA. And then I had one that was 5 and 5. Just to figure out which of these results in the greatest percentage of germination. So it waits a full 2 years in its entirety, because I was working also with some viburnum, and they had a strange situation where the radicle, or the root, would develop the first year, and then it had to go through a whole nother stratification cycle before the top would grow. You're saying that even the radicle was not emerging the first year, right?
Yeah. So sometimes we would get a few random seedlings that would appear after the first year, but the majority of the population would not come out to the second year. And during that time, that's when we, lost many of our seeds to animals. So
yeah, that's a very in the feed stage. They're very at risk. But they've actually done studies. I know that I read one where I couldn't quote who and where, but on red maple, that 50% of the population would wait till the second year to germinate. And it's actually a good strategy if you're growing in a variable climate. Maybe that first year wasn't the most conducive to nursing along a brand new seedling. Maybe that second year would be better. And so not having all of your eggs in one basket really helps perpetuate the genes of that tree. So, yeah, it is known in some instances where they don't germinate the first year. I didn't realize that japonica was one, so that's fun to know.
What were you finding with Acer shirosawinum? Was that a higher level of variability there with Acer shirosawinum? I know it seems to be that that's probably second after palmatum in the cultivar trade as the next most variability within that smaller section of palmata that's pretty popular for cultivars.
I didn't have any of those to work with.
Okay.
I remember that later in the game I was given one from Dale Barong.
Okay.
It was gorgeous.
We recently hiked up Gregory Bald to look at native azaleas and reconnected with Dale Barong, which was fun.
Oh, cool. Yeah, I think it might be more common on the West Coast. I've not. Anyway, I didn't have that in my my plants to work with, so I can't speak to that one.
So, Sue, on Acer pseudosubuldianum, Acer subuldianum, Acer shirosawinum, I know you probably didn't work much with Acer shirosawinum, but on these other species in section palmata, Acer pseudosubuldianum, is that the most cold tolerant, you believe?
Yes.
And is Acer subuldianum fairly cold tolerant as well, or is it just?
No. It's found in more southern Japan, and it's not. So pseudosubuldianum goes all the way across to the Korean Peninsula,
mm-hmm.
and gets into a little bit more continental climate in
mm-hmm.
colder temperatures. So that's where it grows in addition to growing on the islands of Japan.
So what research would you recommend next if you could do anything? What's the final frontier for Japanese maple breeding, or at least what's the next frontier, not the final, because there's a million things we could always do. But what do you think is the next thing that should be looked at when it comes to specific Japanese maple breeding?
I don't know. This may have even been addressed, but I find that so I consider, like, I'm on the edge of the prairie. I'm on the edge of where you can grow a lot of stuff.
Yeah.
And there's a lot of leaf burn. And it would be fun for me to see, I know that there are morphological differences in the number of the palisade layer, or the orientation of the leaves that are developed in the sun and in the shade. And I wonder if there are, if it would be possible to select for more wind and sun tolerant leaves.
Mm-hmm.
Yeah, I think that'd be something that can definitely be done.
I know in looking through Vertree's book,
mm-hmm.
that there would be some that they would say, this is more sun tolerant, but I don't know if it's been quantified. And I don't know if, you say, well, it might be sun tolerant in this climate, but not in the real intense heat and winds of the upper Midwest. So I'm a little self-serving in that
Yeah, that makes
in
sense.
that question.
I think some of that might be accomplished by trying to work with oliveranum and pseudosubuldianum together, and seeing what results. I know that our Acer oliveranum hot blonde, it prefers the sun.
Wow, that's so surprising.
Yeah, and it prefers the sun, and I mean, it will grow much faster in the sun than it will in the shade. So I think that is part of the equation, and then figuring out the equation on how to get that into those colder zones with something that's more wind tolerant might be the other part. But it is definitely more vigorous and prefers the sunlight versus the shade. So I think we've got maybe one part of the equation there.
Well, Sue, with your research, did you look much into Acer robustum, which I think now is kind of packed into Serapharum?
No. But I was interested in the snakebark maple. I talked my boss into allowing me to go on a trip around Lake Michigan in his trusty little F-150, looking for the most westerly and northerly populations of snakebark. So in this case, it would be Pennsylvanicum.
Yeah.
And I did bring some back. It was a little disconcerting because in every single site that I found it was within sight or sound of the Great Lakes. So you knew that that environment had been influenced by the proximity to moisture. But there are, so I talked about the micranthum and Chinoskii. They're a little bit on the smaller side, and I think the bark interest that they would present, it's different from just a straight color. It's actually just that striping. And they have these elongate floral clusters, and the flowers of micranthum, they're true flowers. They've got these beautiful little sepals that are different colors from the petals, white and pink and bright pink. I was thinking, if I were to ever get back into bonsai, that would be the sort of thing that I would search out, because it's the most charming little plant. And it has a palmately lobed leaf and serrate along the sides, and just these very pointy tips. It's a beautiful little plant, and I'm thinking it's especially further south where I am not, it would be a lovely addition to a maple collector's garden.
There's so many traits there that just are underutilized and underlooked at. I mean, I think that's a perfect example. Is there any things that you would consider in that more Japanese maple family that you think should be looked at more for its flowering interest?
Well, I always appreciated working with the Japonicum flowers. They were large enough to work with quite easily. And also it tends to be a little bit taller plant, so you can get underneath them where you can see the bottom sides of the flowers. It's a really nice tree in that respect. So marketing them as being a flowering, ornamental flowering tree, I think is really true to what it is.
Yeah, I agree.
It just made me think more and more about the snake barks. Matt and I have recently found out in the last few years that snake barks can be grafted to Acer truncatum, and makes me wonder if there's any truncatum or hybrids that could recur with some of the snake barks, because sometimes the grafting compatibility can sometimes indicate some relation, and then if you have it grafted onto truncatum, you may be affecting the timing of the blooming, which can be a natural barrier for some of these plants to cross. So it'd be interesting to see if we could get some more heat tolerant, sun resistant, and faster, more developed for landscape use snakebark varieties.
Yeah. Truncatum is a really interesting one. It can have some phenomenal fall color, and it combines well with platanoides. I don't know how concerned you all are about some of the invasiveness of a few of the taxa. platanoides when I did an internship at the Morris Arboretum in Philadelphia, and their Wissahickon Valley had become converted from sugar maple to Norway maple because the Norway maple was more shade tolerant than even the sugar maple, which in our biomes is the ultimate. But it was displacing them, and so trying to figure out. So, got to bring up a name here. Keith Warren.
Johansson.
Keith Warren.
Oh,
Keith Warren.
Out at J. Frank Schmidt had a couple of crosses, Norwegian Sunset and
Pacific Sunset.
But yes, and so they're gorgeous plants. I like the concept that Harold Pellett had of incorporating one more step. And he had been working with Tom Rainey at Fletcher, North Carolina, developing sterile triploids.
Yeah.
So when you get this beautiful, beautiful ornamental tree that unfortunately grows so well that it might become a problem.
You don't want to create a monster.
Growing that one extra step of making a triploid that is not going to be producing seed and becoming pervasive all over the place. So that's one of the things that I think should be considered. And that was also one of the reasons that I was kind of cautious about the working with the Janella maple. I had been hiking at Afton State Park here in Minnesota, and I was in the middle of this supposed natural area, and there is a Janella seedling, and that got me a little bit alarmed.
Oh, I understand. There's definitely a moral obligation to have our native plants involved in the discussion when creating some of these hybrids for sure. And I think that step is well worth part of the conservation and making sense, especially with Acer platanoides.
And on top of that too, just in the yard, people don't want their yard filled with tons of seedlings. When they plant one tree, they want one tree there, and they don't want a billion seedlings all around their yard. So, I mean, I get that with Acer platanoides, but you also get that with some of the natives, and some of the natives will just throw tons and tons of seeds. And for a yard purpose, some of the natives are very invasive as well.
Yeah.
So I totally get that
but definitely a moral obligation to make sure you're not creating a monster here in the landscape. We don't need more Bradford pear-like plants.
I was faced with that with a lot of the directions that I was going in my breeding program, saying, well, you're trying to produce a plant that's going to do really well in adverse conditions. Isn't that kind of like the definition of a weed?
I don't think you could ever produce an Acer japonicum that I considered a weed. I don't care. The ugliest Acer japonicum's better than much else out there. But it's certainly interesting, and definitely with your work with creating, smaller overall plants and more cold tolerant overall plants, I think it's just super fascinating. It's an area, definitely more stuff needs to be done. And I think your work is some of the most interesting as far as it pertains to Japanese maples in the industry. We all owe you a great debt because it's fascinating stuff, and you've laid a lot of blueprints for how to look into more things in the future too. But I think it's groundbreaking stuff that I find super interesting.
Yeah, I think this quest that you have for hardier type, smaller stature maples that you developed, that it really has me and Matt on the warpath, trying to figure out how do we develop these maples that are unique, different, but also ones that can grow in hotter zones, ones that can grow in colder zones, ones that can be more alkaline tolerant, ones that can really expand what people think about with Japanese maples. So
our development programs here, we joke about it being a development program. We call our hidden greenhouses with all our little random seedlings we found the Area 51 so that nothing comes in or out of there. And we're not doing that high level breeding stuff. We're more likely to find seed we know came from a specific Pseudocybuldianum as we collected it from a Ceboldianum cultivar and then evaluate that for ornamental traits. But that's something we're doing here still, looking for, commercially viable traits that we like on species that we at least know one of the parent plants comes from that set of genetics.
But you definitely have opened my eyes again. And when I was a little kid, I would get out there and try to go out and breed daylilies. And you've definitely opened my eyes. And I may get back out there and start collecting maple pollen whenever the blooms start opening up again. I'd got into the method of, it's going to be something that may self itself a bunch, and you always need to just look through a large amount of seed and see what you find. And I may keep doing that, but it may start being that we start doing some crosses as well.
Yeah. Well, I'm glad that you've taken up the mantle and are going forward. And hopefully some of the stuff that I figured out or added to the body of literature will help you and others. Because it's another way of really getting involved with your plants, is to figure out, like, when are they doing their blooming? Do they bloom males first or females first? Or do I need one of each type? And it becomes a more intimate relationship with your specimens.
Mm-hmm.
It's really a phenomenal interaction. It's kind of like having pets.
I agree. I care about these things so much. I think it's one of those ultimate interactions you can have with plants when you care this much about the genetics and what you're looking at and how interesting. And it's super exciting. I think one of the reasons we love doing this podcast too is to open our customers up to new and interesting ideas. And so I really appreciate you being on here today. I think this might be an area that, maybe more in depth than a lot of people are even used to, but I think it's so fascinating. We've probably opened more people up today to, kind of thinking about our plants a little bit differently.
Yeah. Great.
And
thank you for doing that.
And I don't know if you know this or not, Sue, but I know you were a former president of the Maple Society. Matt was the Maple Society president as well. And then I took on the mantle after that for a number of years. So we're
taking that break period now. We're just enjoying showing up again. That was a long period of planning meetings. So.
Yeah.
Hey, we really appreciate you and everything you've done for Maples, and just thank you so much for being on our podcast here today. I think it's a lot of fun. I know I've had a lot of fun talking to you about this. I find this stuff so next level and interesting. So just thank you for that.
Well, I appreciate your interest, and it's really fun to have fellow plant nerds to talk over some of these things. It's great to share these little nuances that you can't just drop these concepts to someone who's not been in the trenches themselves. So thank you for doing that next layer of improvements.
Well, Sue, if you're ever traveling south, our door is always open. If we're about 20 minutes from Asheville, come visit sometime. We'd love to show you around our little operation. You're certainly an inspiration and someone who's been a big influence on us from the Maple Society, and we just love your passion for it. It's certainly something that inspires us.
Yeah, if any of your work ever finds you at the research center in Fletcher, that is 15 minutes away. so
well, that sounds like fun. I'd really definitely want to have access to Area 51.
Sounds good. You've got full clearance. I mean, you've seen more aliens than us, maybe. So we called it Area 51. Oh, go ahead.
Yeah, because of Roswell. But you'd be pretty safe in assuming I wouldn't be hot fingering anything because it wouldn't grow here anyway. So, yeah, it's.
We called it Area 51 because people would come here and shop at the nursery while Tim and I were gone, and Dad would sell them the thing we had one of. That was our experimental new thing, and so it became, this is Area 51, and no one comes in or out of this greenhouse without clearance. So that's kind of where the joke came about, that we were calling our collection Area 51, is that those are the things we had to hide in the back somewhere that everybody didn't take off with.
Yep, that's a good policy. Yeah.
Sue, thanks so much for being on here today. We just greatly appreciate you.
Well, thanks for reaching out. This has been a lot of fun.
Thanks, Sue. Take care.
Take care.
Okay, bye-bye.
Bye. Wow. Thanks so much to Sue. That was just an amazing conversation. I learned something, and I hope you guys did too. That's why we do these podcasts. We want to open you up to new and interesting ways to talk about Japanese maples and a lot more. I mean, but we really like to focus on Japanese maples, and I hope this one gave you a whole different perspective of everything that goes into that tree you have in the landscape.
Yeah, I mean, Dr. Susan Weigriff, she is amazing. I mean, I plant geek out every time I talk with her and learn something new and exciting. I mean, I really didn't want to get off the phone, but I knew she had other things to do. I wanted to keep asking her time. I wanted to keep asking her more and more questions. But I mean,
some people, when you talk to them, you just feel like you got to the source of knowledge on the entire topic. And Sue is definitely one of those people. Like, you feel like you talked to one of the ultimate authorities. And we did. I mean, she is the ultimate authority on a lot of this information. But it's so fun to talk to people that are that smart. And especially not having a background in horticulture, for me, it's so much fun to pick her brain and to just ask questions. And she's always been one that is so gracious with her time. I mean, starting back at that Maple Society meeting where we kind of buddied up to her and had a million questions, she certainly sparked our mind into the possibilities of what could be.
Yeah, I mean, I just remember her looking around and her saying, you know, these circinatums over here have more yellow fall color. These over here have more red fall color. It could be a pH difference in the soil, but it could be genetic variability. So collect from both and then see what you get. And it just, you know, it just continued to progress and go further and further with all these different maples that we've been growing. And every time I talk to her, it feels like my mind just slightly opens more and more to being like, wow, look at all these possibilities. Look at what we could do here. Look what we could do there.
I know several things she talks about over my head, and I learn something every time I listen to her. And this will be a podcast I'll listen to multiple times. So I hope this is something that you guys enjoy, that's something new and interesting. And that's definitely what we try to bring with this. I mean, we look at the Mr. Maple Show podcast as a talk show about Japanese maples and adjacent plants. So that's really what we're trying to do here, is bring you something new and interesting. And I don't think there's anybody better to talk about, you know, plant breeding than Sue Wiegrefe. I mean, she's at the forefront and one of the most knowledgeable people. There's no studies that come after her that don't quote her, right? I mean, that's kind of how you know when you're at the source.
I just love the fact that we recorded this. I can go back and listen to this over and over again.
We make some of this content selfishly for ourselves. And this is one of those for sure.
This is definitely one of those. I know I learned a bunch. I hope that you learned a bunch or were able to plant geek out a little bit like us as well. This just outstanding. I love talking with Sue, and I hope we can have a lot more interesting conversations with others going forward too about some of these unique possibilities in Japanese maples. I'm just speechless.
Guys, if you like this kind of content, definitely go to your favorite podcast platform. We're on all major podcast platforms. Rate us 5 stars on there. You know, if you're a YouTube watcher, we're airing these videos every single Sunday at 8 p.m. There's a live chat that is just ruckus. Those guys are great. They cause a lot of mayhem. Sometimes they're not even discussing the video. They're just discussing, you know, what they loved this week in Japanese maples. So definitely check out that. It's a fun community you're going to want to be a part of on our YouTube show. And that's just the Mr. Maple Show, same as our podcast platform, the Mr. Maple Show. But definitely sub us on all those. And we really appreciate you guys tuning in. We get to make this content because you guys watch it. So definitely share it with your gardening friends. It's a great way to get more people involved in the community we're building here, and just expressing our love and passion for Japanese maples.
Yeah, we really appreciate y'all as listeners. We appreciate those on YouTube who are watching us, and thank y'all so much for supporting us. Remember always, too, if you really want to support our channel, you can support our channel by shopping on MrMaple.com. We're a mail order business. We ship directly to your door, and we carry over 1,000 varieties of Japanese maples, a lot of varieties of azaleas, hydrangeas, and other unique woody ornamentals.
Take care.
God bless.
And have a great day.